Hello everybody and welcome back and thank you for joining me. So, in this video I want to look at inequalities for A-level mathematics and AS. First part will be for everybody and the second bit will be just A-level only, looking at discriminant inequalities. Okay, so from GCSE, if I told you that x plus 5 is greater than 0, then you can tell me that x is greater than minus 5. Okay, so that's our first basic example. A second example that can get a bit more complicated is if we had x, I don't know, 2x, actually no, minus 2x is greater than 4. If we try that one, then we'd get x. What would x be? Well, x, you have to flip the sign if you're dividing by a negative. So x would be less than 4 over minus 2, so it'd be minus 2. So if you're dividing or multiplying by a negative, you must change the sign. So divide or multiply by a negative implies change sign. Make a note there. Okay, so something that can get more complicated with linears is if I had x plus 7 over 2 is greater than or equal to x plus 4 over 3. So dealing with something like that. Now, it's not difficult in any way, because there's two ways you can do it. I would take that away from both sides, the x plus 4, so I've got x plus 7 over x plus 2. Take away that full fraction is greater than or equal to 0, and then I've got some algebraic fractions to get on common denominators. So I have 3x plus 21 over 6, making common denominators, minus 2x plus 8 all over 6 is greater than or equal to 0. I'm not showing full stage of the working, so you should be able to do these. I can combine them so I get x. So adding the negative, so it'll be 21 add minus 8, so that will be x. Take 3, so take 13. All up 6 is greater than or equal to 0. And we get x minus 13 is greater than or equal to 6. And we get x is greater than or equal to 19. So for example, if I stuck 20 into the original problem, I get 27 over 2 is greater than or equal to 24, so it'll be greater than 8. Now 27 over 2 is 13.5 greater than or equal to 8. That is true, so we know we have found the correct solution. Okay, so they're a bit more complicated because I have to include algebraic fractions within them, but when you get down to a single fraction, it can just multiply up and solve. So they're slightly harder, those, but they're not the hardest that you can come across, because the next stage is quadratic inequalities. I don't want to spend too long on linears because they are basic GCSE material, and I don't want to go through those because they're basics. So, quadratic inequalities then. If something's a quadratic, we know if I had x squared plus 5x plus 4, I can put that equivalent to x plus 4, x plus 1 by factorising. Now, you're going to see, if I said that x squared plus 5x, 54 plus 5x plus 4, is greater than or equal to 0, how would you solve that? Well, I've got this quadratic I can factorise, which I neatly have done. Firstly, which is greater than or equal to 0. Now, what this saying is that where is this graph above the x-axis, and essentially. So this is the x-axis, but this means above, and this is talking about the curve or the graph. So where is the curve above the x-axis? So if I draw a very wonky pair of axes, so this is crossing at -4 and -1, and there's no repeated roots because the discriminant is greater than 0, so I can quite happily create a nice curve through there. So what do we need to find out here? Well, we need to find out, actually you don't even need the y-axis here, you just need the x-axis. So where is the graph above the x-axis? Well, that is when x is greater than or equal to -1, and when x is less than or equal to -4. So I have two separate inequalities. Okay, so they're two separate. Now, that's too basic for us, so let's make it a bit difficult, shall we? Let's say we had, I don't know, x squared plus 6x plus, I don't know, 7? Right, we'll have 5 again. Okay, so we want to find where is the graph less than 0. How do we solve that? Well, we can do x plus 5 and x plus 1, so factorising again. We need now this time where is the graph below the x-axis. Okay, so we want x, so it'll be -5 and -1. Got the curve here. That's a bit of a wonky curve, but still, could make it a bit lower, I guess. Don't forget, it's just a sketch. Where's the graph below? Well, that is in this region here. So that is this time between 2. So that is a single inequality. Okay. So they get a bit harder, as you will see. That is pretty much what you need to know if you're doing AS. In this video, I'm not including shading regions. I'll do that separately. Or linear programming, as people call it. I'll do that separately. So the next part of this video is including what's called discriminant inequalities. Now, as far as I know from checking the textbooks for all the exam boards, this is on the full A level. So if you're doing AS, forget this bit. Or you can continue watching if you wish. You don't need to because it's not on your spec. So discriminant inequalities. Okay, so what's the discriminant? Well, the discriminant is a bit underneath the square root of the quadratic formula, which is it's greater than 0 if b squared minus 4ac is less than 0, or if b squared minus 4ac is equal to 0. And we know different bits. Greater than 0, it has one distinct root. If it's equal to 0, it's got one repeated root. And then it has no real roots if it's less than 0. No real solutions. Okay. Alright then. So we have to go at this example where find the values of k such that 6 minus k cubed minus k, also x squared plus 4kx plus 1 equals 0, has distinct real roots / solutions. So if it has distinct real roots, then this is what I want to be using here. I want to say that b squared minus 4ac is greater than 0. To do that, I need to find the coefficients a, b, c. So to find a, this would be 6 minus k cubed minus k, using the ax squared plus bx plus c equals 0 for a standard quadratic. The b will be the 4k, and the c is just the 1. So subbing back in, I have 4k all squared minus 4 lots of 6 minus k cubed minus k, and the c, which is 1. Expanding that, make sure I square the 4 as well as the k, so I get 16k squared. Now if you're not comfortable with multiplying out 3 with a single bracket, you might not be, so if I do 4 down there, and I usually split this into 3 in a table, and do 6 minus k cubed, just so you don't get mixed up with the negatives, get 24, don't forget it's a minus 4 as well, so it's minus 24, plus k cubed, and plus 4k. Plus 4k cubed, should I say. Okay. So, this is minus 24 plus 4k cubed plus 4k is still greater than 0. Simplifying that now, we can divide everything through by 4, so I'll put the coefficients that start bigger and decrease them as you should, so we get k cubed, 16 over 4 will give you plus 4k squared, and then the 4k will drop down to a k, and then the minus 24 will drop down to minus 6, and that is greater than 0. Okay, so it's getting a bit harder, but I need to deal with this now. There is a cubic solver on the calculator that a lot of you will have. If you don't know how to solve this, there is a cubic function, and it will form into triple brackets. We have x. Now this will be plus 1, usually. Well, it's not going to be in this case, it's actually going to be a minus 1. And we have x plus 2 and x plus 3. You want to expand that? You can do, but instead of putting x, I am going to put k. So I'm going to use k as the replacement to find the values of k. Just to make sure I'm not finding the values of x, I'm finding the values of k. So, and we need to find where this graph is above the x-axis. So if I draw this nice cubic curve on this graph, then we have minus 2, minus 3 and plus 1. So let me make that graph a bit longer. We have minus 2, minus 3 and 1. Okay, so this is a cubic that starts in the bottom left and goes through like so. We need to find where is the graph above the x-axis. Well, it's above it there, and it's above it in this section here. So we have two separate inequalities. We need to stick the k, because this is the k-axis, and then that is less than or equal to minus 3. Don't forget they can be equal to as well as not, like so. I'll leave them like that just so it satisfies the question. And the other one, well, it's going to be k is greater than 1, so k is greater than 1, or 1 is less than k. Either of those will be fine. You can also flip this around if you like to. I usually put the small and the big, that's just the way I write these. And that is how we can do a more complicated question on discriminant inequalities. So, thanks very much for watching this video, and hopefully you learnt something new about discriminant inequalities, the only new bit of learning for A-level mathematics. And if you want to find all the videos that I'm going to do in this series for A-level maths, you can find them in my shop on not my shop, in the videos linked. Also, all the music that I've been using in this video is also linked in the description. Remember, those aren't affiliate links, so you can't click on those, and you will not help me at all. So, thanks for watching, and I'll see you in the next one. Peace out. Bye for now. Math Boy out here.